All right, Dmitry Udovik, Marine Mammals Monitoring and Mitigation Measures System. Colleagues, I would like to speak about monitoring and mitigation of impact on marine mammals if we speak about industrial exploration of the shelf. Well, there's a number of organizations doing this. So the first one is CMI MGU. It is an innovative research and technical organization, and their main purpose is to conduct marine surveys and research in order to commercialize various developments. Then another organization, it is called Marine Center. So they are doing research and exploration works and engineering planning in the basin, in the basins, and on shelves and marine areas. It was established in 2015. This project I'm speaking about, it is supported by the SME Foundation. It is a public organization, and they are supporting various innovations and high-tech developments. Now, a couple of words about this project. We are doing it within the fifth window of the competition of the Foundation for Developing Innovations. And there's a number of stages presented here. First, it is development of design documentation and prototype, then development of specific modules, and then assembly of the system, and so on. We have already developed the model and prototypes of this model and the specific elements of it. That was done during the first stage. Then, second stage, we developed trial modules and we had them tested. And also special software was developed. Now we are at a third stage, and it is expected that the whole system will be put together and we are going to test the software. Then we'll move on to the fourth stage when we are going to deal with all the bugs and the final prototype will be developed, and then we will develop the final version, and then we are going to register intellectual property and so on. Right, let's have a look at the system. The system, this monitoring system works as follows. So first, there's an active sampling module and a passive module. Okay, so there's a special hydrolocator, and also we use hydrophonic equipment. They are at a distance from each other, and also there is a pressure sensor there. So you see that some of the elements, they are onshore and some elements are on board a ship. Then we see that there's visualization of data coming into the equipment. Okay, so there are various screens, yeah, and there's this dashboard with all the data, and there's an operator who is monitoring all this. 6 and 8. Okay, so this comes from the passive receptor. And there is a processing unit, and again another operator who is using special software and who is actually doing this acoustic monitoring. 9 and 10, this is visual monitoring. This is more traditional, where we just use naked eye monitoring and binoculars. We have added a software, and all this data can be incorporated into the database, and all this will simplify observation and monitoring. So this number 11 circle, this is an accumulation of all the information from 3 levels of monitoring. And in such a way, we can not only store this data, but also we can adjust what will be the output and how this data will be processed. Right, so system 2. Okay, so there are, so this is the active acoustic monitoring. So there's a special hydrolocator and the frequency is 62.5 kilohertz and above. We use sonar equipment and their frequency is 67.5 kilohertz. And the capture of information is done on the basis of the weight and the speed of the specific animal. Then this passive acoustic monitoring, this is equipment produced by Z Lab. They are installed and then there's a cable. So they are installed on shore or close to the shore. And then there's a 4-line cable for connection. And we also have a special processor and a transformer, because we deal with analog information here. And also we have a working station of the operator who is sitting in front of the computer with specific software. This is passive acoustic monitoring, so we cannot specify exactly any information about specific animals. So this is a new module, and it will be further developed, and it will be possible to introduce some recognition modules there. And finally, the third level, it is a visual monitoring unit. It is special software for registering information on sightings, and also there will be mapping information and GIS information. So all this will be supported with information on the date and time, coordinates of this encounter, speed of the ship, and so on. All this will be done automatically without any operator needed. Right, now then system 2, it is see the functions that we need to incorporate. Okay, so identifying the marine mammal, then identification of the direction it is moving in, then take into account all possible climate and weather conditions. Finally, all the data are standardized, and it is possible to process and retrieve it using different criteria. This unit allows a timely identification of marine mammals. Also, it can use vocalization for this, and it determines the weight and movement characteristics. Safety. Now, a couple of words about safety of this method. The design distance is 1620 meters. Then the working frequency is around 60 kilohertz. So we are reducing this frequency level to the average level, not to disturb baleen whales, because their frequency range is wider. And so toothed and baleen whales are not disturbed. Then not later than 30 minutes before the procedure, there is so-called a slow start. And then after 20 minutes of scanning of 2 regimes, there's deactivation. Yeah, so it should be deactivated, or the ship should move at a distance of over 1,500 meters. Now, some examples of using this sonar equipment all over the world. For example, beginning from 2010, they've been using it in North Ireland, then in the Caribbean. Okay, so they were using this high-frequency sonar equipment in order to avoid moving along the routes of whales for the ships, and also these units are used for identification of sperm whales when there's high-speed shipping lines involved. And we are planning to use this information to minimize the influence of low-frequency hydroacoustic equipment of the US Navy. So not to damage toothed whales or baleen whales. Okay, so there's special equipment, high frequency, and if an animal, a marine mammal, is identified, then the low frequency is switched off. Okay, and the whole point is to minimize any negative impact. And I would like to stress that all this is used not to research or localize or register mammals. No, all this is done only to minimize various acoustic systems. You have only 1 minute left. Okay, in 2019, we did it near Sakhalin. We did 4 registrations. Actually, we registered 4 animals during this testing of the project equipment. The active unit, this hydrophonic equipment, okay, it got the sound, then it was amplified, okay, and this is what we see in the end. Yeah, so this is the monitor screen. Then the station of the operator, okay, Windows 10, MS Office, then the program for capturing the visual information and the acoustic information. As for visual monitoring, okay, so this is a system that allows a registration of all sightings of marine mammals. And in conclusion, we can say that the system combines 3 types of getting and registering information on marine mammals. And also it is possible to identify the type of species, and also it minimizes the negative impact of shipping, for example. And the major idea is to combine visual registration and acoustic information. We are using different sensors, and in future, this will make shipping more animal friendly, and also it will be possible to use it in research activities. Thank you for your attention. Dmitry, thank you very much. A most interesting report. Yeah, but we don't have any time for questions.